In the real world, you have many relationships which are of the type is a relationship. If you consider vehicles, a car is a vehicle, a jeep is a vehicle, a truck is a vehicle. All of these is a vehicles can be modeled using inheritance in Python. Let's see an example of how we get classes to inherit from one another here. We'll start off with the very basic inheritance. We have a class named shape. We want to specify no other characteristics of shape, which is why within the shape class, we simply say pass. You use the pass keyword when you do not want any code to execute there. So we have a class named shape, but there's no code within it. So we say pass. Python allows you to define a class by using slightly different syntactical forms. For example, this is also a correct definition within Python, the class shape followed by brackets. Or you can have class shape and indicate that it inherits from the object. The object is the base class for all classes in Python. The object need not be explicitly specified though. So we'll go with the first definition. That's what we'll use throughout this course. This base class shape has exactly one member variable called type, which indicates what type of shape this is. Is it a circle? Is it a rectangle? Is it a triangle? And so on. The init function takes in the shape type as an input argument and assigns it to the underscore underscore type variable. You want all classes of type shape to implement certain member functions, and you can define these member functions here, that is the get area and the get perimeter. Because each shape calculates its area and perimeter in a different way, there is no code that can be present for this in the base class, which is why we have the pass keyword. We don't want to define how to get the area and perimeter of a class in the base class. We'll do it in the derived class. With the shape class defined, we can instantiate an object of type shape. We pass in the shape type to this. This is a circle. Now this is stored in variable s, and if we call s.getArea, nothing happens. That's because these functions do not have any code within them. The pass keyword that we used in the get area and get perimeter functions for shape basically mean there's no code to execute here. Nothing happens when we call get area or get perimeter. Now we can go ahead and define a class for a specific type of shape. We'll set up the circle class which inherits from shape. Now the way you specify what this class inherits from is by specifying the base class within brackets. So specify shape within the brackets of circle. That means circle inherits from shape. Circle is a shape. The init method within the circle class takes in the radius of the circle as an input argument. Now, the init method of the circle class can call the init method of the shape class. You can simply invoke shape dot underscore underscore init underscore underscore. Make sure you pass in the self parameter as well as the shape type. If you remember, the init method of the shape class takes in as its input argument the shape type. The radius, which is the input argument to the init method of the circle class, is assigned to a member variable within the circle class. The circle class has actual definitions for the get area and the get perimeter methods, pi r square and 2 pi r. This has to actually implement these methods because they are not implemented in the base class, if you remember. Let's go ahead and instantiate a circle of radius 10. This is assigned to the variable c. You can call c.getArea and c.getPerimeter, and it will print these out. Notice that when we instantiate a circle, the get area and the get perimeter functions invoke the corresponding code which is present within the circle class. It doesn't invoke the code that's present in the shape class. Even though the circle is a shape and the shape class has the same get area and get perimeter methods, the code that is executed or the methods that are invoked are the ones in the circle class. That's because CR variable knows that it is a circle. The correct methods from the derived class are called at runtime. C knows it is of type circle. This is runtime polymorphism. We can set up other derived classes from the shape base class as well. The class square is also derived from shape. This class takes in one input argument during initialization, the length of one side of the square. This class within the init method once again calls the init method of the shape base class and indicates that the shape type is square. The length of the side of the square is stored in the side member variable belonging to the square class. The square class will have its own implementation of the getArea function and the getPerimeter function. Let's go ahead and instantiate a square of side 10. We can now call s.getArea to get the area of the square and s.getPerimeter to get the perimeter of the square. Notice that the area and perimeter calculations are done correctly. You see runtime polymorphism at work. S knows it's a square. It calls the correct getArea and getPerimeter functions from the square class. The idea of modeling user relationships using inheritance is to allow for reuse of code. For example, all things that are common across all shapes can be pulled up into the base class. For example, you might have a shape class where there is a shape type and a color associated with the shape. The color can be associated with any shape, whether it's a triangle, rectangle, it doesn't change, which is why the color can be part of the base class characteristics. We'll have a function which allows us to update the color of a particular shape. Now, this function's code can be present in the base class itself because this code is not going to be different whether the shape is a square or a circle or you name it. The code for the method to get the color of a particular shape can also be in the base class. There need not be specific implementations in the derived class for this. However, calculating the area and perimeter cannot be done in the base shape class because this calculation is different based on what kind of shape this is. Which is why we put in the get area and get perimeter methods here to indicate that all shapes have these methods on them, but we say pass, we execute no code when these methods are called on the shape class directly. Let's set up a circle class as before. It takes as its input the radius of this circle. It calls the init method of the base class and passes in circle as the shape type. Assign the value of the radius that's passed in to the radius member variable and set up the functions get area and get perimeter. Make sure you perform the appropriate calculations for a circle. We'll go ahead and set up a new circle object. This circle has the radius 12. On this circle object, you can call the set color method and change the color of your circle. This set color will invoke the code that is present in the base shape class. You can invoke this method on the circle object because a circle is basically a shape and the methods on the shape class is available in circle as well. You can also call c.getColor and this will invoke the method which we've defined in the shape class. Our circle's color is blue, that's what we had set earlier.